Let us now discuss KMP algorithm. But before that, let us see how the normal brute force search works. So let's assume this is a string value. You have A, B, 5 A's and then B. And you have the key value as B. So let us write down the index values 0, 1, 2, 3, 4, 7, 8, 9 and 10. Here 0, 1, 2. So initially you will be starting with the first index values, that is, you will be comparing 0 and 0. Are they matching? Yes. Then you will be incrementing and you will be going to 1, 1. So are they matching? Yes. Then you will be going to 2, 2. Are they matching? No, because here you have A and here you have B. Then what you will do is wherever you started, again you will start after the next one. Okay. So now the comparison will be here 1 and here 0. 1, 0. Are they matching? So 1 and 0. Yes, both are yes. Then you will be comparing 2, 1. That is, you will be incrementing each by 1. So 2 and 1. Are they matching? Yes. Then you will be comparing 3, 2. So 3 in the string index. So this is the string index and this is the key index. Okay. 3 and 2. They are not matching because here you have A and here you have B. They are not matching. Okay. So what will you do? Again, you will start at 2 here. So you will start 2, 0. Are they matching? 2 and 0? Yes. Then you will be comparing 3, 1. So 3 and 1. Are they matching? Yes. Then you will be comparing 4, 2. So 4, here you have B and here you have B. They are matching. Now you have reached the end of the key. So what you will say is, yes, key is found in the string because here it is AAB, here it is AAB. So let us assume we had some variable called count is equal to 0. Now because you have found a match, you will be incrementing it to 1. After that, because now you have found the match at 4 and 2, you will be starting fresh. You will be starting 5, 0 because you have found a key. So you are coming to 5 and here it will be the 0th index. So A, are they matching? Yes. Then it will be 6, 1. So A and A matching. Then 7 and 2. So 7 we have A and 2 we have B. So it is not matching. So where did you start? You started in 5, right? Here you started. So again you will start at 6 now. So now 6 and 0. Are they matching? Yes. Then 7, 1. So 7 and 1 here both are A. So they are matching. So 8, 2. A and B, they are not matching. So again you will start from 7. So you will be matching 7, 0. Both are A's. Then 8, 1. So both are A's. Then 9, 2. So 9 A and B 2. They are not matching. So again you will start from 8. Index 8. Okay. So here index 8, what will you do? 8, 0. Are they matching? Yes, both are A's. 9, 1. Both are A's. Here also, here also. Then you will be coming to 10, 2 and 10 you have B and 2 you have B. It is matching. Now you have reached the end of the key, which means you have found a match. So the count will be incremented from 1 to 2. Okay. Because after that it will be 11, 0 because here you have found one thing and you don't have index 11 here. So you stop. So now the result is that you have found 2 instances of key in the string. But here if you observe, it is going back and forth. Like after coming to 6, it is going to 7 and then coming back to 6. Similarly, 7, 8, 7, 8. It is going back and forth in the string value. So this algorithm, brute force search, is not optimized. In KMP algorithm, we will not be going back with the index value in the string. It will stay at the same place in the worst case. Okay. So let us look at the KMP algorithm. But before that, what is the KMP algorithm trying to do? Let me explain. So it is trying to find the longest prefix suffix sequence. Okay. So let's say we have a string value like A, 4 A's followed by B. So here it is trying to find which is the longest prefix that is also a suffix which is occurring at a later part of the stage. So the prefix strictly starts from the initial letter, but the suffix does not end with the last letter. Okay. It can be occurring anywhere after the prefix, that is after the first letter. Okay. So here, which one is the longest prefix that is also occurring at a later point of time? So you cannot say 4 A's. Okay, 4 A's. Because it can be a prefix, but it cannot be a suffix, because after the first letter it should start. That is the condition. Okay. So here the longest prefix, which is also a suffix, will be A. Because when you have A, so this will be the prefix, and the suffix, it should not include the first letter, right? It will be this. Okay. So this we can get it using the LPS array. So how to form the LPS array? Let's say we have the same string A, B. So what we will do is we will write down the index values 0, 1, 2, 3, 4. So always in the first index place a 0. That is, this is the LPS array. Okay, LPS array. So let's say we have an array like this, and we have the values here 0. So now compare 1 and 0. That is, you are comparing for index 1 and 0. Are they equal? Yes. Then you increment. The length is 1. Then you are going to compare 2 and 1. Are they equal? Then you increment with whatever the value it is being compared. So 1 will become 2. Then you are going to compare 3 and 2. Are they equal? Yes. So you are comparing 2 in the LPS, right? So 2 plus 1, 3. So next you are going to compare 4 and 3, because whenever it is matching, you have to keep on increasing. Okay. So 4 and 3. So 4 and 3 are not matching. Now you should not immediately go back to 0 as in the brute force approach. So now you are at index 3. What is the previous value? 2. So you have to compare 4 and 2. Then 4 and 2 are also not matching. Then at 2, what is the previous value? You have to compare 4 and 1. So 4 and 1 also not matching, BA. Then you have to go to the previous one, 4 and 0. 4 and 0, they are also not matching. Now before 0 you cannot go. So only at this point of time you should yield and say, okay, I am not able to find a match, and put a 0 here. Okay. So this is the idea of forming LPS. So from here, what are you trying to do? What is the maximum value here in this LPS array? It is 3, which means a suffix of length 3 is there, which is same as the prefix. So from here 3 means you go 3 characters here, it is A. So what is the prefix array? Matching prefix array, A here. So now let me give you one more example. So we will have this key, okay, this string value C, C. Okay. So now let us write down the index values 0, 1, 2, 3, 4, 5, 6, 7, 8. So now we will have the LPS array over here. So initially you are going to populate 0 here. So now you are going to compare 1 and 0. Are they equal? Yes. So you add 1 to this 0. So it will become 1. Now you are going to compare 2 and 1. So 2 and 1, are they equal? No, they are not equal. So now what is the index 1? What is the previous value? 0. So you are going to compare 2 and 0. 2 and 0, they are not equal. Now before 0 you cannot go. So you add a 0 here. So now which one are you going to compare? 3 and 0. Okay, you are going to compare 3 and 0. Are they equal? Yes. So add 1 to this index value. It is 1. Now you are going to compare 4 and 1. 4 and 1. Are they equal? Yeah. 4 you have here and A you have here. So add 1 to this one. So it is 2. Now you are going to compare 5 and 2. 5 and 2. Are they equal? No. Because AC, right? So now what are you going to do? This is index 2. What is the previous value? So you are here at index 2 and the previous value is 1. Okay. So you are going to compare 5 and 1. So 5 and 1, A, both are matching. Okay. So what is the index value here? 1. You add 1 to this. So that will be the value, which is 2. So now because 5 and 1 are matching, you go to 6 and 2. So 6 and 2, AC, they are not matching. So now you are at index 2, right? So you are going to compare with the previous one, 6, 1. So 6 and 1, both are A's. So what are you going to do? This 1 plus 1 you are going to place, because this is the index in the LPS array which we are going to compare. Okay, right? So 1 plus 1 is 2. Because it is matching, you are going to 7, 2. So what is the value at 7? It is A. A and C, they are not matching. So this is the index 2, right? What is the previous value there? It is 1. So you are going to compare 7 and 1. So because 7 and 1 both are A's, it is matching. This index value plus 1, you place it here. So now you are going to compare 8 and 2. So 8 is C and 2 is also C. Both are matching. So what should you do? Add 1 to this. 2 plus 1, 3. So after that, you are going to make it 9, 3, but those index values don't exist here. So you stop. So now this LPS array, what is it saying? So at this place, right, at this 8th index, you are having a prefix which is of size 3, which is repeating here. So that you can observe. From here, size 3 means AAC. Okay. So you can also observe you have the prefix of length 3, AAC here. So the advantage of having the LPS array is when you are searching for this key in yet another string, okay, suppose there is a mismatch, okay, suppose there is a mismatch when occurring at this index, you don't go straight away to the 0th index and compare again like in the brute force. So what is the previous index? 2, which means you are not going to 0th index, but you are going to start the search from the 2nd index, okay, you are going to start the search, continue the search from 2nd index. Okay, so it is an optimization. So this optimization, let us observe using an example. So let's say we have a string value. We have A, B, and then we have A, B, C. Okay, so this is the string value and the key will be AAB. So let's have some AAB, AA also. Okay. So now let us write down the index values for this 0, 1, 2, 3, 4. Let us write down the LPS array for that. So we will populate the LPS array value 0 and then you are comparing 1 with 0, it is matching. Then 2 with 1, it is not matching. Then again 2 with 0, you are comparing, it is not matching. So you will have a 0. Then A and this A, this 3 and 0 you will be comparing, it is 1. Then this A and this A you will compare, it is 2. So this is the LPS array. Let us write down the index value for this string 1, 2, 3, 10. So initially you will be comparing 0 and 0, 0, 0. So they are matching. So you will go to 1, 1. So this is the string index, this is the key index. Okay, here that is in the LPS array plus the key. The length are same, so it will be the key index. 1, 1. Is it matching? Yes. Then you will go to 2, 2. So 2, 2, it is not matching. Now, should you go all the way to 0? No. So here you are, key index. What is the previous value? 1. So you are going to compare 2 with 1. So 2 with 1, yeah, it is matching. Then what will you do? You will go to 3, 2. So 3 and 2, it is not matching. So second index, what is the previous value? It is 1. So you will be going to 3, 1. So 3 and 1, they are matching. So you will be going to 4, 2. So 4 and 2, BB, they are matching. Okay, so you will be going to 5, 3, right? 5, 3. So now at 5, what is the value? It is A. And 3 also it is A. So you will be going to 6, 4. So 6 it is A and 4 also it is A. So you will be going to 7, 5. But you don't have a 5 here. So whenever a 5 is coming, you know that the key is entirely in this because A, B, A, right? So here you have found the match, right? Here you have found the match. So you can increment the counter, found counter from 0 to 1. So now, because you have reached the end of the one, next you have to compare 7 with 0. Okay. So 7 with 0, it is matching. So 8 with 1. So 8 and 1, it is matching. 9 and 2. So B and B, it is matching. So it is 10 and 3. So 10, C, and here you are not finding a match. So at third index, what is the previous value? It is 0. So you are again comparing 10 and 0. It is C and A. They are not matching. But because now you have reached 0, so you don't want to have any more comparison. You increment and 11, 0 comes. But there is no 11th index here. So you stop the search. So how many times it is occurring? This key is occurring here. It is 1. So what is the optimization that the KMP is giving? Here if you observe, the string index value never goes back as in the brute force. So it stays at the value and more comparisons are made, but it does not go back. Okay, it only only in the key index it goes back to the point where it is optimal using the LPS array and it searches. If you observe, this is only in increasing order, it never goes back. Okay, so this is the optimization KMP gives over the brute force when we are solving. So let's say we have this string instead of this C. Okay, we have A, B, A and another one A in the 11th index. Okay, then how would it have proceeded? So here let me erase till 9 2. So after 9 2, what would have happened? 9 and 2, they are matching. So 10 and 3 would have come. So 10 and 3 matching, yes. So 11 and 4. So this 11 and 4 matching, yes. So now it would have gone to 12 5, but you don't have 5 index here and 12 index here also, which means a key has matched, because the moment it has reached 5, you know all the characters in the key are covered, which means we have found a match, right? So then the counter will be increased to 2. So even here, when the key is occurring twice in the string, the string index is not going back at all. Okay, it will be staying there to compare. Like here in 2 it stays. Okay, it stays twice and then after comparison you increment. Only when the key index goes to 0, the index value of the string will be increased, or in the case of matching, the string index will be increased, but it will never go back. Okay, so with this performance optimization, we will be able to iterate over the characters in the str, that is the string, the parent string where we have to search the key. We will be iterating the characters only once. So based on our discussion, please solve the program, and thanks for watching.